Hi students, welcome to the video lectures of speech and natural language processing. So today we shall discuss about word level analysis, n-grams and evaluating the n-grams. These are the topics which we are going to learn today. First, it is word level analysis. So what is word level analysis? So it involves the examination of words in a text to understand their structure, meaning and relationships within sentences. It is a fundamental aspect of NLP and is essential for various applications, including text analysis, sentiment analysis, and machine translation. So how this word level analysis is done and what would be the key concepts in it are the following. The first one is tokenization. So tokenization refers to splitting of the words into splitting of the given text into some individual words. We have seen a couple of tokenization examples also in our previous video lectures. Then second one is morphological analysis. So morphological analysis is it's the study of the structure of the words and the meaningful components, what we call them as morphemes, which is also have been discussed in our previous classes. Then it's POS tagging, we say, that is parts of speech tagging, which is essential to identify each word in a sentence, whether it is a noun or verb or adjective or whatever. Then it is word representation. So word representation is about the vectorization and about the one hot encoding part, or about the examples what we have also talked about, like word to a glove, all these which will represent the words in a continuous order, so like vectorization, what we do for our models, for our machine learning models. And then we talk about semantic analysis as well. So when I say semantic analysis, we talk about word sense disambiguation, where it takes this task of determining like what is the exact meaning of the word which is being used in some context, right? Then it is about n-grams. So n-grams are nothing but we had a couple of discussions in our previous video lectures about n-grams, what are n-grams and how this unigram, bigram, trigram are divided and all those things. Then about stemming and lemmatization, both try to reduce the words to their base or root forms, but only difference what we could find between them is like stemming is not bothered about generating a valid word as an output, whereas lemmatization will ensure that it will give us the valid word as an output. And so when we talk about frequency analysis, we'll discuss about term frequency, inverse document frequency, and all those things. So like when I say term frequency, we already know like how often a word will appear in a document or a input, whatever the text part that you take, that falls under frequency analysis. So then about n-grams. So n-grams is a contiguous sequence of n items from a given text or speech sample. So in NLP, these items are typically words or characters, and n-grams helps in modeling language and capturing the structure of word sequences. So types of n-grams are unigram, bigram, trigram, higher order n-grams. When I say unigram, it is 1 gram. So why it is 1 gram? So we had already seen this in our previous video lectures, but I'll just again brief you regarding these unigram, which is also called 1 gram. That is, for example, if I say I love NLP, so what does this unigram does? So uni is 1, which means it divides or splits the given text into individual words. That is, I is considered as one token, love is considered another token, and NLP will be considered as another token. That is how unigram works. When it comes to the bigram, if you consider the same example, I love could be 1 and love NLP could be the other. That means bigram, it is 2 gram. So the sequence of 2 words, we can say, the sequence of 2 consecutive words or characters, we can say, that exist for a given sentence. So a given sentence is I love NLP. So I love will be 1 and love NLP would be the other. When I say trigram for the same example, I love NLP, which is already in a trigram. That means it has already divided into 3 and formed a sentence. So higher order n-grams, when I say that is 4 or more. So the given example have only 3 words, so which can be useful for only our top 3 examples, that is unigram, bigram, and trigram, since the given sentence is in trigram format. So when I say this, let's just jump to another example, like I love learning NLP, right? So that sounds to be consecutive 4 words, which we call as 4 gram or higher order n-grams. So that's how these types of n-grams are discussed. Then we talk about the applications. So when I say applications, here it's first is language modeling. So when I say language modeling, we have had a couple of lectures in our previous videos as well, where language modeling, we had seen grammar-based language modeling, statistical-based language modeling, and all those things. It's simply to say that what does language modeling does is it tries to predict the next word in a sequence just by doing some analysis or considering the previous words. And also sometimes it goes with statistical language models where it learns from the patterns and try to predict the next coming word. So then next is text classification. So basically, these engrams are used as features in our ML models for tasks like spam detection or sentiment analysis, and sometimes for document classification as well. So then we talk about machine translation. So this also done to predict the consecutive sequence of words, like in during a statistical machine translation process, it will try to predict. Then it is about speech recognition. So engrams generally are used in these automatic speech recognition ASR devices in order to predict the next word. Then it is about named entity recognition. So when we say named entity recognition, it is all about identifying the entity that is present in the whole sentence. So the entities are nothing but for a given sentence, it will try to pick the words and it will try to tag them with the proper entity. Either it's an organization or a location or quantity or what else. So it will identify its entity. So then we have challenges in these engrams. So challenges means first one would be data sparsity challenge. So what it is saying is, as n increases, the number of possible engrams grows exponentially. So whenever the number of words or your the text for the given text, the engrams will try to divide it into some couple of words. It splits into some engrams. So when n increases, the number of possible engrams grows exponentially. So this can lead to sparsity, where many engrams are rarely or never observed in the training data. So as far as this is concerned, this is fine. But the only problem, I mean, there will be a problem for especially the higher order engrams. Till trigram, I think the model will work. But when you consider the problem of this data sparsity for higher order or 4 gram or more than 4 gram kind of data, there will be a problem. So second would be curse of dimensionality. So what is curse of dimensionality? So higher order engrams require larger data sets to capture meaningful patterns. For example, let us take a trigram model. Okay, when we consider a trigram model means it have three. In our previous example, we have seen I love NLP. So these three words, when combined, is said to be a trigram model. So we generally need some some data with enough examples of every possible sequence of the words in order to predict. So when we don't have this proper or enough sufficient data with us, it's unable to do the task. Then we talk about context limitation. So engrams only capture local context, that is the immediate neighboring words. They do not take into account larger dependencies in the text. Like, for example, the meaning of a sentence will depend on words farther apart from your engram window, what it could capture actually, right? So that is your context limitation. So then we talk about evaluating engrams. So evaluating engrams is evaluating engram models involves measuring the performance and accuracy of an engram-based language model or system. The effectiveness of engrams is typically measured by how well the model predicts sequence of words or characters and how it performs in specific NLP tasks, such as text generation, machine translation, or speech recognition. So there are a few certain evaluation metrics to mention here. So first one is perplexity. So basically, the perplexity is common metric which is used to evaluate the quality of N models, particularly language models. So basically, what it does is, it measures it in the sense the perplexity. It will measure how well the probability distribution or the model what we have tried will predict a sample. So if there is a lower perplexity, then the model is said to be a better one. And if there is a higher perplexity, the model is said to be not performing well. That's how it is calculated. And given is the formula for perplexity of the occurrence of the word. So where here it is mentioned perplexity, the probability is mentioned word 1, word 2, and so on till word n is the probability assigned by the model to the sequence of words. That the sequence of words are word 1, word 2, and so on, word n, and n is the number of words in the sentence. So basically, whenever the engram has been implemented, it tries to take the number of engrams which are present in the given sentence. Suppose, for example, it calculates the perplexity for trigram, bigram, and unigram as well. So by incorporating those into the formula, what it does is it finally gives you the perplexity of one particular thing. So suppose if I say the perplexity of unigram is 100, perplexity of bigram is 200, perplexity of trigram is 300. So as I told you earlier, before starting of evaluation of the engrams, lower the perplexity, the better the model. That means a lower perplexity will indicate you that the model is working well. Understand? So that means, so now in the given example where I told you unigram have a perplexity of 100, let us assume. So the other are having 200 and 300 consecutively. That is your bigram and trigram. So unigram is the best, since it is having lower perplexity, it has a better model. That's what the perplexity is. So then we talk about precision, recall, and F1 scores. So whenever I say precision, recall, and F1 scores, so let us try to understand them. So precision will measure how many of the n-grams predicted by the model are actually correct. So, in other words, we can also tell the precision like, it's the proportion of, correctly predicted n-grams among all the n-grams which are predicted by the model. Got this? The proportion of correctly predicted n-grams among all the n-grams predicted by the model. This can also be another definition. So the formula for your precision is given as, so true positives by true positives plus false positives. All right. Then it is about recall next. So when basically the recall measures how many of the actual n-grams in the test data were correctly predicted by the model. Okay. So in other words, we can also say as, so recall will measure how many of the true n-grams from the reference text the model successfully have predicted. Okay. So it is the proportion of correctly predicted n-grams among all the true n-grams in the reference. That can also be your recall. So the formula is, equation is the recall is equal to true positives by true positive plus false negatives. So to explain this, you can consider one example. If there were, suppose let us imagine some 15 true bigrams in the reference translation model, but the actual model have correctly predicted 7 out of these 15. So the recall would be 7 by 15, which is equal to 0.47. So which means we will say that the model has predicted 47% of the actual bigrams which are present in the reference. That's how we can talk about recall. Then it's about F1 score, the harmonic mean of the precision and recall, where this F1 score will try to balance the two metrics, to give a single measure of a model's performance. Right. So the formula is 2 into precision into recall by precision plus recall. This is the formula for your F1 score calculation. Where the only thing what you have to understand in F1 score is it always takes into the account of both your precision and recall for giving a balanced equation. Okay. So, thank you, students.